So just before we start, I don't know if you've noticed, I've adopted a new brother. His name is Benjamin, as you can see here. Tried to get the hair close to the family's DNA, but didn't work very well. So Benjamin is joining me. Actually, I'm joining Benjamin. Benjamin will run season 2. He's also our query processing tech lead based in Munich, building and scaling the office there. I've met Benjamin 2-3 years now. How long ago, Benji?
Probably like 2
years ago. He got in touch. He was an intern thinking about his PhD in Munich University, and one thing led to another. And here we are today with you, talking about data. So I'm really looking forward. And with that, Benji, it's all yours.
Awesome. So you're introducing me, and I'll just go on and introduce our guest, Vijaye. Yeah, thank you so much for joining us today. So Vijaye is the CNO and founder of Statsig, and he founded Statsig in February 2021, if I'm not mistaken. They're based in Bellevue, Washington. Their original office was in Kirtland, where Firebolt also has an engineering office. And Statsig is building a product observability platform, and we'll talk more about that later. Basically, it makes it super easy to manage feature flags and experimentation. And yeah, we're excited to have you. So they raised a Series A in August 2021, and now in April of this year, a 42 million Series B, led by Sequoia and Madrona. So that's awesome. Yeah, and Vijaye didn't start out as a startup founder. He started out in big tech, actually. So he spent his first 10 years at Microsoft doing a variety of different things, and then joined Facebook in 2011, where he stayed for another decade. And there he led Facebook Video and Gaming, and was also the site lead for Facebook Seattle. So he scaled the site there from just a handful to more than 5,000 engineers, which is pretty impressive. Yeah. So
one out of those 5,000 used to work for you. He works for Firebolt now, and we got great feedback. So we're happy and excited.
I love it.
Awesome. Perfect. So Vijaye, do you want to give a 2-minute high-level overview about yourself, about what Statsig is doing, before we dive into some of the nitty-gritty details?
Absolutely. Hey guys, thanks for having me. I'm honored to be here on the first episode of season 2. Excited to be here and chatting with you both. So Benjamin, you covered the history a little bit. I started Statsig about 20 months ago, and this is after spending 10 years at Facebook. So I joined Facebook in 2011 when Facebook was still considered a startup, a small startup. And then, obviously the company grew both globally as well as in Seattle. So I spent my time also growing the Seattle offices from, like you said, a handful of folks to, I think when I left, about 6,500 people. And one of the things that struck me as I moved from Microsoft to Facebook, I was always an engineer. So I grew up and learned programming and wanted to be an engineer. And I spent 10 years at Microsoft as an engineer. And during this 10 years, it's kind of like formative when you see the software processes evolved. And it went from this shrink box software that sits on Best Buy shelves to shipping every single day, and then eventually continuously shipping code. Those are the things that I learned firsthand at Facebook, and I was fascinated by that whole concept of how you decouple feature launches from code launches, and the tools that were associated with it, the tools that kept this chaos from getting out of control. And also started understanding how you measure the impact of every single feature you ship, and then throw away code that doesn't work because you thought it would work doesn't mean it would. And then measuring every single change actually gives you a lot of insights, a lot of humility, I think, and then also a lot of cultural changes. And so those are definitely resonated very strongly to me, to the point where I said okay, this is important, that we should go build a company around these set of tools. And that's why in February 2021, I left Facebook and started Statsig. I brought with me a few folks and joined and built the tools. And then now the company is going strong. We have now 52 people as of yesterday. So pretty exciting growth.
How was it switching from this huge organization, engineering organization, to a startup that just now got to 52 people? How does it feel?
It's crazy. Going into a startup, I thought I knew some things, but then over time, I realized I had absolutely no idea what I was doing. It's like really jumping off a cliff with not a parachute, but just instructions to assemble a parachute, and then you have to figure it all out before you land. And that's kind of like how it feels. It's managing an org of like thousands of folks is very different skill than building a startup from scratch, hiring the first person, the first engineer, the first product manager, first designer, and then getting a product out. It's kind of like, when you're building early days, you're building in a vacuum. You kind of like have this vision, you have this, you believe in this thing, and then you go build, and then you put it out. You're really vulnerable, right? So you build out your product and you put it out for somebody to come and like take a look at it, and you hope somebody would like it, and then will use it, give some feedback. And then for 6 months, you sit there and like nobody is touching your product, and you're like wondering, oh, what have I done? I made the worst decision of my life. But then slowly, the traction happens. Slowly, people like starting to notice, and then they're like, oh, this is actually a pretty useful product. And then you go from like this one stage to another stage where people are now even trying out your product for free, and then eventually they want to actually use it, and then eventually they want to actually pay for the software, and then eventually they love the product, and then they actually want to like evangelize the product. So you go through these stages, and each of these stages, you're constantly like questioning yourself and questioning your decisions. It is a fascinating journey that all startup founders go through, and this is my, like you said, I spend all my life in large companies where you don't have to worry about this kind of stuff. And then when you throw it into a startup, every little thing matters. So yeah, it's been a fun journey, very, very much a learning journey, very much humbling just to like look around and see how many people that have gone through the same journey as me before and been successful.
And you just started. There's a long journey ahead. Yeah, it is.
I know. I know. Yeah, definitely.
And
it's only been 20 months.
You picked great timing, as well, because I think kind of raising round B, like perfect. Yeah, it is. Yeah. It is. Those are crazy times building startups. It's always crazy building startups, but those times are especially crazy. Benjamin is young, so everything is new, and but we've been there through previous recessions, and it's always surprising how different each time it is. Yeah. But I wouldn't replace it for anything, and really, we look forward to hear more about what you're building.
Yeah, thanks.
Awesome. So let's dive right into that. So maybe for our listeners who weren't exposed to, I don't know, A/B testing, experimentation, all those things yet, do you want to give like the kind of 2-minute pitch of why this matters and what it actually is?
Yeah. So one of the most important things is when you're building a product, you have a hypothesis, and you think that something that you're building is going to be beneficial for your users or your customers or for your business. And that hypothesis is baked into every single feature that you're building. And the idea that we build those things out and then ship it to people without really like instrumenting or measuring whether that particular belief is actually true or not is no longer valid. It's no longer okay. And at Facebook, I remember this, where 80% of the code that you write or the products or the features that you build don't work on first try. Which means that you have to like go back to the drawing board, iterate on the product until it works, or sometimes throw away your idea, and it's okay because you can't be right all the time. But knowing which 80% is not working, which 20% is working is the hard part. So that, just understanding and measuring the impact of the changes that you're making to your product, to your users, to your customers is extremely important. So the stage number one is always about measuring things that you build and ship to people. Stage number two is like, okay, well, taking the measurement back and then actually addressing some of these causal inferences. Like, okay, well, why did the metrics do what they're doing? Can we attribute it to the changes that we made? And then make the decision, okay, well, what do we need to do in order to whether double down on it because it's doing really well or wind it down because it's not doing well. And so those are the kinds of tools that people need access to in order to be able to make the right decisions on the product on a daily basis. The state of the art in the industry currently today about experimentation is still A/B testing, and A/B testing is like it's the gold standard for causal inference. However, it's very, very time-consuming and manually. There's a lot of overhead because you have to first come up with a hypothesis, you have to build the variance, and then ship out the variance, and then you have to allocate the samples, isolate the experiment, run it for however long it takes for statistical significance, maybe 2 weeks, maybe 3 weeks, and then you have your data science team go back and look at and analyze all of these results. And this whole process takes a long time. And so most people don't run that many experiments. They pick some of these features that are really, really important, and then they run it through the A/B testing experimentation pipeline. The rest of the features just go out untested. So this is where I think like companies like Facebook, Uber, Airbnb, and even LinkedIn, some of these companies have like sophisticated tools that basically take every single code change you're making, feature change you're making, and then have tools that'll automatically run these A/B testing, and then will give you back the results of the impact of those changes. Thereby, you don't have to do the previously mentioned like long process of A/B testing. You kind of like get these results on a daily basis, and then you make decisions which will be much better decisions than before. And that's what we're trying to build with Statsig. It's kind of like where we're going with this product observability.
Gotcha. I mean, you have a background, right, in like gaming at Facebook, for example. Do you have like one or two grippy examples of things where like this kind of mattered, or where these types of experiments kind of led to interesting insights?
Oh, a lot of them. Like I say, one of the key metrics that I share is like 80% of the code or 80% of the features that we think we are going to be beneficial are not. And so just going back to the drawing board is a regular thing, and it's okay. And that way people don't get attached to the code they write. So I'll give you one anecdote. So in video specifically, we have run plenty of experiments. And the general belief is that the higher the quality of video that you're able to provide, the more consumption that will happen, because obviously people like higher quality videos. And so, at Facebook, we built this automatic bitrate detection code, which basically constantly analyzes your network stability, last mile bandwidth, and all of that stuff to be able to okay, well, we're going to give you the best possible bitrate for the connection that you have. And so far, that's been experimented and proven, and we continue to increase and increase and increase. Like encoding have gone up from a 480p to 720p to 1080p, and then eventually 4K. And the belief is yes, that is always good. And then in 2020, the pandemic hit, and when most people stayed home, the media consumption grew pretty heavily. Almost over a course of a month, it doubled and tripled. And some of the backbones, like the carriers and the ISPs, they couldn't basically handle the load. And so there are some of these folks reached out to Facebook and hey, could you help? Because a lot of the traffic that is going out is going to Facebook, and a lot of it is for video. Could you throttle these for us? And we were like, oh my goodness! If we start throttling, that's actually going to reduce the consumption. That's actually going to leave people not feeling great about the quality and the experience. But we also understand that this is kind of not normal terms. It's kind of crazy times that we're dealing with. So we went ahead and started tweaking our ABR algorithm to actually give couple clicks lower bitrate than what was actually possible to give.
I always knew this 4K isn't a real 4K when I saw it. Something felt fishy there.
No, it's we actually showed that we're dropping, and then if people wanted to pick 4K, they could go ahead and pick the higher bandwidth. It's just the automatic default that we pick, and when we change the default, normally obviously we experiment with everything, right? So this is one of those things where when we changed the defaults, we were actually looking at the metrics that were coming in. We were shocked because the usage actually went up. People were using video a lot more and consuming video a lot more with the lower bitrate. And, obviously this was surprising. This was new. It's okay, well, we would have only known because we ran these experiments for every single change we make. And then we went back and we looked and we did some case studies and we talked to folks. And then later on, we understood that there's a segment of population that is very bandwidth sensitive, and they have, whether they're throttled or whether they're limited bandwidth and so on, where generally they get constrained by how much per day that they can use. And so now all of a sudden, a whole batch of people were now able to use or consume more video than they did before. And then there's a whole segment of population that were on the phone that are kind of old, outdated phones where 4K or 1080p doesn't actually make a difference. And so, trying to push more and more bitrate was actually not necessary. So there's a set of learning that we had that was very interesting. We wouldn't have had those learnings if not for this kind of experimentation, constant experimentation. Anyways, it was pretty eye-opening for me as I was running the video org.
Right. I mean, that's pretty interesting, right? Because when I looked at this first and I was like, oh, kind of maybe this is about, I don't know, the color of your pay now button on the shopping cart. But these are really deep, algorithmic kind of core parts of your infrastructure to which you then apply those experiments. So that's kind of cool to see.
Yeah, that's absolutely right. I mean, a lot of people, when they think about A/B testing, you're naturally gravitated towards oh, well, let's change the text of the button or the color of the button or change the layout of where things go in order to get more conversion. I mean, I think those are also valid A/B tests, but those are also very they're kind of more marketing centric and more shallow because your metrics that you're trying to move are directly correlated to the product changes. Whereas when you touch okay, well, I'm going to change the parsing library that's in the back end, and then I want to see if that increases any latency on the large segment population, especially at scale. Those are the kinds of things that that you actually care about when you're modifying product, and you want to verify that there are no obviously where you want to verify that it's actually doing what you expect to do. And then secondarily, you want to verify that there are no extreme side effects. Sometimes you don't know what's going to happen when you actually make these changes. So monitoring those things are important.
So let's talk a bit about what powers actually infrastructure like this. So the actual experimentation infrastructure. The first question I would have is, so say I want to run this experiment now, right? I'm an IC at a company. I have this type of experimentation software. And now I'm saying, okay, my video encoding algorithm, I want to change that and see if XYZ increases. Do I have to be the one formulating the hypothesis? Do I have to be the one saying, oh, I changed the thing and I think XYZ might increase? Or is it there's some core metric someone else from the product team defined, and then each experiment is actually tested against these same core metrics? How does it work?
Yeah. So generally what you want to be keeping track of is there are some business critical metrics. You don't want to drop those business critical metrics. You want to make sure that they are healthy for across all of the product changes that you're making. And then there are all these metrics that you're kind of the primary metrics that you expect to change, expect to move. Okay, well, if I'm changing my video encoding algorithm, I expect more video watches to happen or more time spent on videos to happen. And then perhaps even lesser lag or lesser interruptions in the video because of bandwidth issues. So those are the kinds of things that you would normally be watching as a direct result of the change you're making. So those are, I think, those two separate set of metrics that you should be watching. And one of them is probably picked by your company level, product or growth leader. So you kind of like, okay, well, I don't want to ever drop my DAU or engagement or retention or, obviously revenue and things like that. And then the other one is generally like determined by the product team that is making product changes, very close to those metrics. I think both are extremely important. And then generally, like, more sophisticated tools like Statsig, one of the things that we provide is kind of like guardrails. So you can basically specify like if this particular metric, say my DAU metric, drops by below 3%, then I want an alert to fire and people to be notified. And so anytime anybody is changing any product, if that drops the metric by 3%, you want to be aware of that, and you want to be able to like get right to the problem of like, well, what's happening. And obviously, you can also like have these trade-off conversations whether it is worth it or not, but that's up to you.
What actually powers these things in the background, right? Like there must be some pretty sophisticated statistics or something going on. And like one thing I just thought about, like, what about correlation in experiments, for example, right? So kind of I on my team am changing the, video encoding. Another team is changing how much video gets buffered. And in the end, like we're dropping this kind of into production at the same time. Like somehow you have to figure out which change actually changes the kind of core metrics you're interested in.
Yeah, no, this is a very good question. So obviously, there's a lot of teams that are changing a lot of things. One of the things, obviously, you would not launch every product that you're making 100% to the user. So you kind of like are splitting the audience into smaller portions and rolling it out. Typically, we use this exponential rollout model where you take a new feature, you roll it out to 1% of people, and then see how it affects the metrics, and then 2%, 5, 10, and then 20, 50, 100. So that's kind of like the sequence that you normally follow through, and making sure that every stage you're not dropping any critical metric more than necessary. And when multiple people are doing those, the salt or the randomization for each of these rollouts is different. And so different sets of population will get these different sets of features. There will be some intersection, and the rest of them are getting their unique experiences. And that's kind of like how our system determines like how to attribute a metric change back to the actual feature change. And that's why we also have error bars in our confidence intervals. And then you'll be able to like, once the error bars are within statistical significance, then we turn them into either green or red, depending on if it's positive or negative. And since that kind of like, have our stats engine determine the causal inference back to the features. Now, obviously, there are lots of things that you could also employ the tools to validate some of these. So if you have multiple features that are highly interactive in nature, so okay, I'm changing something in the product that are very closely tied to each other, then what you do is you have isolated experiments. So you kind of like create a layer, which is called a universe, in other words, and then you actually say like, I'm going to allocate 25% of this universe or layer to this particular experiment, and another 25% to this experiment. And so you kind of like go like that, and that way, no single user will be getting two different experiences. They'll actually be like isolated and getting one particular experiment that they work on. And that way, you can also like increase your confidence interval. Make the confidence interval better, choose decreasing the confidence interval. At the same time, also like attributed really clearly, okay, well, this experiment is doing these things to my metric. And so those are the kinds of tools that are available. Now, there's also something that you mentioned, which is like, okay, well, if I launch these two things at the same time, what happens? So the interaction effects are kind of like cumulative impact of multiple sets of features. So we have something called holdouts, so long-term holdouts, which are able to like actually measure the cumulative impact of multiple sets of features that you're launching over a course of time. We use this extensively. So basically what that means is like at the beginning of a quarter or the beginning of a half, you specify 1 or 2% of the population that are kind of like in the holdout group. And then you launch a whole set of features. And then you go back and analyze, okay, well, compare all of the metrics to these 1 or 2% of the people that have been held out from these features. That kind of gives you the cumulative impact. So you have all of these tools at your disposal to get all of that information.
How do you manage like the semantic layer of all of that? Like, because it gets so complicated. Like I wouldn't consider myself an engineer anymore, unfortunately. But observability to me always seemed like it's easy to kind of collect the events, but it's impossible to connect those events to kind of a semantic model where you can actually drive the business based on that. And having so many cloud native companies driving their business through their data, through their product, it seems like those kind of platforms are really not just about observability anymore, right? It's kind of really about driving your business. And so is there a standardized way to do it? Is there kind of in the industry, is there a shift towards a semantic, like a DBT for observability or something that will make engineers' life easier to communicate on insight?
Yeah, that's basically what we're trying to build, which is, the sophistication is actually in the stats engine. And that should not make your product building process any more complicated than it already is. And so the idea behind everything that we're building is like engineers should still be building features. And when you decorate a feature with a feature flag, we then take care of like the attribution, the analysis, and then also like try to do it as real time as possible, because you want to get to diagnostics as quickly as possible. You don't want to like put out something that is broken experience for your users for longer than is necessary, and then kind of like catch that as quickly as possible and then fix those things. So while it seems like, okay, there's lots of stuff that is happening, all of that is encapsulated by the complexity of the stats engine. But there is also a layer of like, okay, well, if you make it complicated for people to understand what's really happening, then you've lost. You kind of like have not actually achieved anything. So how do you take all of that data and simplify it? So, some of the visualization innovation that we're doing is to like, okay, how do you make, engineers, product managers, even designers be able to understand the insights easily? However, when a data scientist wants to come in and go and dig into the code, you want to have this like progressive disclosure of complexity. You kind of like want to actually have the ability to dive into the data if somebody is inclined to do so. So that's the challenge, right? The tooling should make it extremely easy for everyone, but at the same time not block you from getting into the details. And that's precisely what we're building. And product observability is like, if you think about it as an extension of like, I always say tools in the data observability space have become so sophisticated. And then if you look in the ops observability, kind of like Datadog or so, you kind of like in real time, you'll know when one server is misbehaving among a forest of like 1,000 servers or 10,000 servers, right? In real time. And that's pretty amazing. So systems have gotten so much more sophisticated than what I remember like 10, 20 years ago. And then when you talk to product folks, you still are kind of like in the, oh yeah, we're going to launch V2 3 weeks from now. And then when V2 launches, we're going to like, wait for 3 weeks for our product adoption to happen. And then we're going to have analytics, our data scientists go and look at the analytics and then have some way of like correlating, are the metrics going up after the feature launch, or are the product launch, are they going down? Why are they doing those things? So, but you see how slow and
it's done manually outside of the system, and so it takes your alpha feature 8 months to go into beta while trying to make observability work. I think it's amazing. I think the next step is really kind of getting observability to be impactful. It's always been a black box for engineers to do their stuff, and seeing observability moving away from just helping engineers do their day job to really driving your business. I think it's a huge step forward. And it's also, if you think engineering, the more data they deal with, the more data that's being impactful, like using those kind of tools becomes not just optional anymore. It's really changing how you build products. And we've seen that firsthand at Firebolt, by the way, how it affects. This is not kind of a hacky, like it starts at let's put a feature flag, but it quickly turns into kind of a way to drive your engineering culture, as you've mentioned at the beginning. So amazing stuff. And now tell us like how complicated is it behind like building observability is the hardest part, right? I mean, it's data-driven, it's real-time, it's metadata is actually changing, unlike your product, which makes it even more challenging.
Yeah.
Can you share a bit with us, kind of how does it work? How do you do it?
So, obviously the credit goes to the data science and the infrastructure engineers that we have at Statsig. These guys are pretty amazing. I'll give you the overview of how we ingest the data and kind of like the infrastructure that we rely on. And then the details of that, is actually beyond me. So let's talk about we have a set of SDKs that help you get started relatively quickly. Now, obviously, building these SDKs is also a pretty interesting problem because, as an engineer, you're excited, okay, well, there's all these technologies. It's like iOS and Android and React Native. And so you got to build SDKs in every single technology because people have all of those out there. And this matrix continues to grow, especially if you have a new feature, you have to test it across, we have 25 SDKs, I think. So 25 SDKs.
The ecosystem team is going crazy.
Yeah. Oh, yeah. We have this on this whiteboard. I'm not kidding. There's this huge matrix where people draw okay, well, have I implemented this feature in this SDK? And then the matrix continues to grow. So that's fascinating. That's step number one. And then once the SDKs are integrated, they're obviously collecting event data and then sending it back to our servers. On the server, we have a queuing system called Event Hub. So basically, the Event Hub is the first stage that actually acquires all of these events and queues them so we don't lose a sequence. And then we have actually a redundant system as well. So once the Event Hub is receiving all of these things, they actually throw it into a file system. It's a big, large file system so that if anything happens to the Event Hub, so we can go back to the data that's sitting on the file system and replay it when necessary.
Vijaye, if I can interrupt, can we take a step back maybe? What is an event actually kind of in this world?
Yeah. No, absolutely. So an event could be as granular as somebody purchased a product in an e-commerce setup, or someone added to cart, and again in an e-commerce setup. In a gaming setup, somebody reached a new level or achieved an accomplishment or achievement. And then in a fintech scenario, someone used a credit card, and so those are all kind of events. And those are the ones that we kind of be able to gather and turn them into metrics, really. So imagine if you have a purchase event and that purchase event happens to have a value, which is actually the dollar amount. Then you can aggregate a sum of all that stuff, and then you can see revenue as a metric. And now you can verify, okay, if I'm making all of these product changes, is it changing my revenue up or down? And that's how we correlate.
These events are then basically annotated with the kind of specific feature flag configuration of that customer or user at that time.
No. Actually, so the events only have user ID information. Mm-hmm. And then on the other side, when we actually deliver the features, you ask for this user ID, which features should we show? So that's the correlation. The join is actually
happening
on
user in the ID. Background. Okay.
Yeah. Nice. So that's
why we joins as someone building database systems.
I love it too, because that actually
there's always a join, Benjamin. Always
a join. Wow.
Always.
Everywhere. But the join is actually powerful because it simplifies the two kind of responsibilities. So if I'm a feature builder, if I'm an engineer, I only have to care about which feature flag am I using? I don't have to worry about all the metrics and annotating the metrics, and we do that for you. And so it's part of actually simplifying how we use the system. So once the events are in our backend, then we throw it into a data lake. And so the data lake is where we do deduping, because sometimes when users are, especially in React setups, kind of constant rendering, you kind of have multiple events generated at the same time. And so you want to dedupe and, do some sanitation of the data and stuff like that. And so we do all of that on the data lake side of things. Then what happens every hour, we have this gigantic Databricks job. This Databricks job is where all of the, the statistical correlation, causation, all of the analysis is all encoded in Python. They basically spin off thousands of servers to go orchestrate all the analysis. And then outcomes basically a set of analytics, and those analytics go back to our data warehouse, and then where we actually like break it down into lots and lots of like pre-computed metrics, so that when you actually go to our console, you'll be able to like get these things in real time, so you don't have to like recompute anything. So the UI is extremely responsive, so you can click around and actually like have things pop up very fast, because that experience is important. Otherwise, if you're sitting for even like 1 minute for every one of these queries to run, then you kind of like lose the whole fluidity. And so we take a lot of care about like making sure that those things are working as quickly as possible.
Cool. So this kind of, right, you have these hourly batch processes like running, which means, say I launch something, kind of, and this experiment starts. After like an hour, 2 hours, I'll start seeing some data on my experiment. What if something goes like terribly wrong, right? So I like did the worst thing ever, and it just breaks everything. Is the safety then that it's only like with 1% of my customers, and so these couple of hours don't hurt a lot? Whereas there like a kind of fail-safe or trapdoor if things go terribly wrong?
Yeah, Benjamin, you want them to fix your bugs as well? I mean, come on.
Sorry.
Don't stretch it too far. Sorry, go ahead.
No, I think that's the important. I think you're hitting the nail, because it's important to roll out slowly in stages. So typically, we see most customers when they create a feature flag, it's open to only employees. And so there's usually this dogfooding process. If something is terribly wrong, you catch it with just employees before it even hits your customers or users. And then what you do is you roll it out to, sometimes some customers have these early adopters that are kind of like a little bit more okay to get some beta experiences, and they're okay to tolerate some of these things that are broken. And so you turn it on to the next ring, and which will be the early adopters. And then obviously you're monitoring all these metrics. Sometimes you get a little bit of scale, which is good. So it's stress testing your product. And so if something is broken, you pause the rollout, you go back and fix it. Then the next stage is like, okay, well, now I'm going to open it up to 1% of the general public, or general. You can pick a country, like, okay, I'm going to open it up only to United States. Sometimes people do that because they don't want to invest in localization, and they want to like test it in English-speaking countries first before everything works. Then you invest in localization, and so you kind of like roll it up to 1% and see how things are, operating. The good thing about this is like, if something is broken, you catch it within an hour. So which is as real time as we can get. And so then you're kind of like going back and like fixing things versus like waiting for your customers to tell you, or some support channel file a ticket, things like that. So those are like, I think, why it's extremely important to like catch these early and fix them. Right. And so one interesting thing is like, because I'll add this here too. A lot of people think that, you need lots of samples in order to like even catch these things. But, if something is broken, you don't need thousands of samples. You need like 10 samples to tell you like, oh my gosh, this particular metric is dropping. So let's go figure out what's going on.
About what volumes of data are we actually talking here? So like how much data are you processing every day?
Oh my gosh, terabytes. And we have about 15 to 20 billion events every single day, give or take, based on like, how, one of our large customers ran a sale for 3 days. And then what happened was like, their volume tripled for a week. And, our system is able to scale and adopt, take care of that. But give or take 15 to 20 billion. And it's been growing like, just 8 months ago, we had 1 million or so events a day. And now we're talking 20 billion events. And those things are raw events, right? And so the job that we need to do is to quickly dedupe and reduce that as much as possible before we like, toss it over to like the Databricks jobs. But the
Benjamin, this is a huge insert into group by the way.
Nice.
Translating to relational algebra, insert into group by.
Now I understand.
Billions of unique events.
I always need those relational algebra trees to understand what's going on.
That's why I'm here.
Yeah. And then what happens after that is like, we actually store all the raw events for when, our customers need, and then they want to be able to like, go download this thing. And when you download, you get this like, a terabyte file, which is pretty crazy. It takes, days to even download. So, and then we offer like several ways to like slice and dice, filter, and like, so you can get your data as quickly as possible, but we store all of that stuff. And so we're not quite at the petabyte yet, but we're quickly approaching that.
Awesome. So what are actually the scalability limits on those pipelines? Like what's harder basically, like growing to 10x more customers or a single customer of like 10x the size? Is it similar? Is it very different? How is that looking?
Yeah, it is very different. I think like, 10x customers is actually easier than one customer growing 10x, especially if that customer is extremely large. Because what happens is like the joins and the analysis that we do are within the same customer's data. We actually like have separation of data, which means these things take much longer and require a lot more orchestration. And so a lot of times it's interesting, some of these things that I never thought we are running into. So for example, one of the things when the Databricks job runs, it spawns out like thousands or so spot instances, spot VMs that then actually go and do the actual heavy lifting. And then to communicate with each of these spot instances, you need local IP addresses, and you run out of IP address allocation. I never thought that you would actually run out of those kind of things. And apparently those are resources. And then you're like, okay, well, how are we going to solve this problem? And then you have to like start thinking about, okay, well,
IPv6.
Pretty much, right? So it is fascinating when you're running some of these jobs at scale with so much data. Even like the choice of like how we store the data, what kind of databases we use, and how we run these orchestrations, like it's been affected, and it's actually like evolving too. So obviously we didn't foresee all of this stuff, so we built something that worked 6 months ago. And then you throw it all away, and then you rebuild based on like what we know now. And I am pretty sure 6 months from now, we'll probably throw all of what we have right now and then rebuild something for whatever scale that we will be dealing with, because those are the times we're actually going to identify some new problem that we haven't even thought about.
Right. So what's, for example, like now on your current stack, an experience where you're saying, wow, we would really like to provide this, but it's kind of something we just can't do on the architecture we have?
Well, I mean, wouldn't it be awesome if we're able to give you more real time than 1 hour? So imagine if we're able to give you like in minutes, 5 minutes, 10 minutes. That would be amazing. And currently, our systems, our architecture, our expense, the cost of infrastructure is prohibitive enough that we cannot provide that. So we have to work with an hour as real time as we could get at this point. But I would love to keep pushing that limit as much as we can, because I think we've gone from many, many weeks to an hour, which is a pretty huge step forward, but we're not going to stop there.
Awesome.
I smell subscriptions. Coming along soon.
Yeah. I think especially as we go into this Web3 world, I'm assuming that's going to become a real time an important issue. So we will have to keep investing.
To wrap up the conversation about your internal data stack, I assume you guys are dog fooding basically, so that you're also using Statsig internally to try out the things you are launching. Do you want to quickly talk about that maybe?
Oh yeah, everything we do is behind the feature flag. So we don't ever throw out any code that that is even a little bit sensitive or a little bit. We want to validate it, and so we throw everything behind a feature flag. And we obviously that gives us the separation of when we can roll out a feature. Sometimes we do an announcement to everyone, and then when we do the announcement is when we open up the feature flag. And so and obviously we are also monitoring how people use these new features. And when we build a new feature, is there adoption to this feature? And then we also like constantly consider, okay, should we invest more in this feature or not? Those are kind of like, product decisions that we make on a daily basis based on the data that we know how people are using our own product. And our marketing side is full of feature flags. Like if you go to our marketing site, the button text in like, the get a demo, that text is actually different for every person. And that is driven by a multi-arm bandit experiment, which is automatically deciding which text actually yields most number of conversions. And then we'll start to show more and more of the winning variants. So we have like 8 different variants that we throw into that system. So so we use Statsig pretty extensively.
And maybe to close up today's podcast episode, we'll shift gears a bit to kind of more like on the advice side for our listeners, right? So on my end, Eldad said it earlier, I have this more academic background, so I'm relatively new to industry. And you've seen all of it, right? Kind of over 3 decades, starting your 3rd decade, 2 at big tech, now at startups. Like, do you have any advice for aspiring engineers, basically?
Yeah, I think as an early engineer, so I've always wanted to, I always chase technology. So in the beginning, I was like, okay, I want to be, for me, the compiler engineers are like gods. And I was like, I want to be like a compiler engineer. So and I went and I was in Microsoft. I worked on compiler technologies. I worked on language services, incremental compilation, and stuff like that.
Benjamin's upcoming paper is on the query compilation. I'm sorry.
Oh, really? I haven't told anyone yet.
We'll cut it out, but we don't cut anything out. So we'll release it after you release the paper. Sorry, go ahead.
3 months.
Yeah, and I went and worked on compilers and for a while, and then over time I kind of started realizing technical problems actually ladder up to user problems. Okay, what user problems are you solving? And so you kind of have a view on okay, this is what the problems are, and those translate into technical problems. And so you start chasing specific user problems that you're interested in solving, so developer problems. And so I worked on lots of developer frameworks in Windows and such. And then over time, you kind of start to realize that a lot of the user problems, after you peel the first couple layers, are kind of about the same. And kind of the technologies that you deal with, the problems that you solve are repeated over and over and over. You kind of start to pattern match and stuff. Then it starts to okay, there are people that I want to follow. Go from technology to user problems to people. You start following people because you kind of pattern match. This person has done things that I want to do. I want to aspire to be these people. And so pick those folks, and then because you don't have to chart your own path. Some of these things have already been done. So follow them, pick good mentors, pick good managers, and learn from them, because there's so much to learn from people that came before you. And then as you grow, then there's an element of turn around and pay back, because just as you grew on the coattails of other great folks, now there are a set of folks that are joining and learning the trade. Turn around and mentor them and coach them, create that followership. I think that's the journey of an engineer. In the last, as you grow in your scope, as you grow in your craft.
Boom. I love it. It doesn't matter where you work. If you're an engineer, and if you love being an engineer, and if you actually think about the problems that you're solving as an engineer, there's no limit. And Benjamin, I hope I've been mentoring you enough. And if not, I will try harder. Because it's future engineering.
What am I supposed to say now, Eldad? Awesome. Well, I think those were great closing words. Thank you so much, Vijaye, for joining us. This was awesome. I think we've all learned a lot of new stuff.
Cool. Well, thanks, guys.
Thank you, Vijaye.
Thanks, Eldad. Thanks, Benjamin. Thanks for having me on your show. I'm looking forward to watching this.
Awesome.
Absolutely.
All right, guys. Take care.
Take care.
Bye-bye. Take care.